NVIDIA Deep Learning. Welcome to Project Ventive. In our today's video, we are going to talk about the NVIDIA Deep Learning. Before the video starts, like and share this video. Also subscribe to our YouTube channel Project Ventive for more updates. The study of artificial intelligence encompasses all aspects of learning, including deep learning, which is a subfield of machine learning. What are the key distinctions between deep learning, machine learning, and artificial intelligence, AI? The study of how to create computers that are capable of carrying out tasks that would ordinarily need human intelligence is what is referred to as artificial intelligence, AI. Because of this definition's lack of specificity, artificial intelligence, AI, covers a wide range of study topics, from genetic algorithms to expert systems, and leaves room for debate on what exactly constitutes AI. Within the realm of artificial intelligence research, the subfield known as machine learning has seen extraordinary progress in recent years. This has enabled computers to outperform humans or get very close to their level of performance in a variety of domains, including facial recognition, speech recognition, and language recognition. The process of teaching a computer how to carry out a task, as opposed to programming it with step-by-step instructions on how to carry out that activity, is referred to as machine learning. When the training phase of machine learning is complete, the system will be able to generate correct forecasts when presented with data. That may sound uninteresting, but those predictions could be used to answer questions, such as whether a piece of fruit in a picture is a banana or an apple, whether a person is crossing in front of a self-driving car, whether the use of the word book in a sentence refers to a paperback or a hotel reservation, whether an email is a spam, or whether speech can be recognized accurately enough to generate captions for a YouTube video. Deep learning is a subfield of both artificial intelligence and machine learning that makes use of artificial neural networks with multiple layers to achieve the highest level of precision possible in a variety of tasks, including object detection, speech recognition, language translation, and others. Deep learning differs from traditional machine learning techniques in that it can automatically learn representations from data such as images, video, or text, without the introduction of hand-coded rules or human domain knowledge. This is in contrast to traditional machine learning techniques, which require the user to have prior domain knowledge. Their extremely adaptable architectures can learn straight from unprocessed data, and can improve their forecast accuracy when given more information to work with. The application of deep learning is widespread throughout apps and is especially prevalent in computer vision, AI conversations, and recommendation systems. Deep learning is utilized by computer vision applications to glean information from digital photographs and movies. Apps that use AI to simulate human conversation enable machines to understand and converse using natural language, to provide search results and services that are meaningful and relevant to the user. Recommendation systems make use of imagery, language, and the user's interests. Deep learning is responsible for several recent advances in artificial intelligence, including Google DeepMind's AlphaGo, self-driving cars, intelligent voice assistants, and a great deal more. Researchers and data scientists may greatly expedite the deep learning training process using NVIDIA GPU accelerated deep learning frameworks. This process, which would normally take days and weeks to complete, can now be completed in just hours and days. When models are ready to be deployed, developers can rely on GPU accelerated inference platforms for the cloud, embedded devices, or self-driving cars to deliver high-performance, low-latency inference for the most computationally intensive deep neural networks. These platforms can be used in a variety of environments, including the cloud, embedded devices, or self-driving cars. NVIDIA Artificial Intelligence Platform for Developers. The development of artificial intelligence applications begins with the training of deep neural networks using extensive datasets. GPU accelerated deep learning frameworks give interfaces to widely used programming languages such as Python and C/C++, as well as the flexibility to create and train individualized deep neural networks. These frameworks also offer deep learning capabilities, because many of the major deep learning frameworks, including PyTorch, TensorFlow, JX, and others, already have GPU acceleration built in. Data scientists and researchers don't need to know how to program GPUs to begin producing useful results within minutes. NVIDIA Tensor Cores. NVIDIA's Ampere and Hopper graphics processing units, GPUs, both of which are powered by tensor cores, provide application developers and AI researchers with an immediate path to quicker training and improved deep learning performance. Your throughput will increase significantly, and the amount of time spent training AI will be cut in half if you enable Tensor Core's FP32 and FP16 mixed precision matrix multiply. Deep Learning SDK provides developers with high-performance libraries that implement building block APIs to directly implement training and inference into their applications. These libraries are geared toward developers who are integrating deep neural networks into cloud-based or embedded software. Because there's only one programming model for every GPU platform, from desktop computers to data centers to embedded devices, software developers can begin development on their desktop computers, scale it up in the cloud, and deploy it to their edge devices with very few or even no changes to the code. NVIDIA offers developers who are interested in creating applications for deep learning using AI models that have already been trained eliminates the need to construct models from scratch or experiment with other open-source models that do not converge. These models have been trained on high-quality representative datasets to deliver state-of-the-art performance and production readiness for a wide range of use cases, including computer vision, speech AI, robotics, natural language processing, healthcare, cybersecurity, and a great number of other applications. Every artificial intelligence framework, boosted deep learning frameworks provide a high-level programming interface with the building pieces necessary for developing, training, and testing deep neural networks. Deep Learning Software Development Kit, SDK, libraries are utilized by all of the major deep learning frameworks, such as PyTorch, TensorFlow, and JAX, to enable high-performance multi-GPU accelerated training. To use GPUs for training, all a framework user needs to do is download the appropriate framework and give it the appropriate instructions. Gain a better understanding of deep learning frameworks and investigate the examples provided here to get started right away. From platform development to deployment, a unified approach. All GPU platforms, from the Titan V desktop developer GPU to the data center grade Tesla GPUs, have been tuned for use with deep learning frameworks. This enables researchers and teams of data scientists to begin on a smaller scale and expand their operations as the amount of data, number of experiments, and team size grows. When a model is ready to be integrated into an application, developers can test and validate it locally on the desktop, and then, with minimal to no code changes, validate and deploy to Tesla data center platforms, Jetson embedded platform, or Drive autonomous driving platform. This is made possible by the fact that the libraries included in the Deep Learning SDK are API compatible across all NVIDIA GPU platforms. By doing so, developer productivity is increased, and the risk of introducing errors during the transition from prototype to production is decreased. The NVIDIA Deep Learning Institute, DLI, can assist you regardless of whether you are an individual searching for training that can be completed at your speed, or a business seeking to improve the abilities of your employees. You can learn how to set up an end-to-end project in 8 hours, or how to apply a specific technology or development technique in 2 hours at any time, any place, with nothing more than your computer and an internet connection. Certain courses can help you get a certificate of competency, which is beneficial for job advancement. 5 of the best GPUs available from NVIDIA for deep learning. Number 1. NVIDIA Titan RTX. The NVIDIA Titan RTX is a graphics processing unit, GPU, designed for high-end gaming that excels in deep learning workloads as well. This graphics processing unit, GPU, was designed specifically for AI researchers and data scientists, and it is driven by NVIDIA Turing TM architecture to provide unrivaled performance. The Titan RTX is the greatest graphics processing unit, GPU, for personal computers. If you want to train neural networks, handle enormous datasets, and create films and visuals with extremely high quality, In addition to this, it is supported by NVIDIA drivers and software development kits, SDKs, which make it possible for producers, researchers, and developers to operate more efficiently and produce better results. Functional specifications: CUDA cores, 4608, tensor cores, 576. Memory for the GPU is 24 GB GDDR6. Memory has a bandwidth of 673 GB per second. Compute APIs: CUDA, DirectCompute, OpenCL trademark. Number 2. NVIDIA Tesla V100. NVIDIA Tesla is the first graphics processing unit, GPU, developed with tensor cores, and it was designed to accelerate activities involving artificial intelligence, high-performance computing, HPC, deep learning, and machine learning. The 125 teraflops of deep learning performance that the Tesla V100 is capable of delivering for both training and inference is powered by NVIDIA Volta architecture. Additionally, it has a lower power consumption compared to other GPUs. Because of its exceptional performance in artificial intelligence and machine learning software, the NVIDIA Tesla is one of the most effective graphics processing units, GPUs, currently available on the market for deep learning. Because of this graphics processing unit, GPU, data scientists and engineers are now free to concentrate on creating the next AI breakthrough rather than maximizing the use of memory. Functional specifications: CUDA cores, 5120, tensor cores, 640. Memory has a bandwidth of 900 GB per second. The memory for the GPU is 16 GB. 1246 MHz is the clock speed. Number 3. Compute APIs: CUDA, DirectCompute, OpenCL trademark, OpenACC NVIDIA Quadro RTX 8000. PNY's NVIDIA Quadro RTX 8000 is the most powerful graphics card ever created, and it was designed specifically for doing matrix multiplications for use in deep learning. Rendering complex professional models with truly precise shadows, reflections, and refractions may be accomplished with a single Quadro RTX 8000 card, allowing users to gain quick insight into their work. Quadro is designed to equip professionals with the most recent hardware, accelerated, real-time ray tracing, deep learning, and advanced shading technologies. It is powered by the NVIDIA Turing TM architecture and the NVIDIA RTX TM platform. Memory can be increased to 96 GB when it is utilized in conjunction with NVLink. Functional specifications: CUDA cores, 4608, tensor cores, 576. The memory for the GPU is 48 GB GDDR6. Memory has a bandwidth of 672 GB per second. Compute APIs: CUDA, DirectCompute, OpenCL trademark. Number 4. NVIDIA Tesla P100. The NVIDIA Tesla P100 is a graphics processing unit, GPU, designed specifically for high-performance computing, HPC, and machine learning. It is based on the NVIDIA Pascal architecture. The lightning fast nodes provided by the Tesla P100 equipped with NVIDIA NVLink technology drastically cut the amount of time needed to find a solution for large-scale applications. A single server node may link up to 8 Tesla P100s through NVLink, which offers 5 times the bandwidth of PCIe. Functional specifications: CUDA cores, tensor cores. Memory for the GPU, the bandwidth of the memory. APIs for computing. Number 5. NVIDIA RTX A6000. The NVIDIA RTX A6000 is one of the most recent graphics processing units, GPUs, and it is fantastic for deep learning. Deep learning techniques and more traditional graphics processing jobs are both within its capabilities because of the Turing architecture on which it is based. Additionally, the RTX A6000 is equipped with a technology known as Deep Learning Super Sampling, DLSS. With the help of this function, photographs of a larger resolution can be rendered, without sacrificing either the quality or the speed of the process. This graphics processing unit, GPU, also comes equipped with several other functions, including a video engine core, a rasterizer core, a texture mapper core, and a geometry processor. Functional specifications: CUDA cores, 10752, tensor cores, 336. The memory for the GPU is 48 gigabytes. Begin your education with some real-world experience. The NVIDIA Deep Learning Institute, DLI, provides developers, data scientists, and researchers with hands-on training in artificial intelligence, AI, and accelerated computing. Through the online, hands-on course that you can move through at your speed, you can earn a certification in the principles of computer vision. In addition, there are optional classes of 2 hours duration on topics such as the creation of digital content, healthcare, and intelligent video analytics. We appreciate your viewing, and we hope you enjoyed the video. How was the video? Did you enjoy it? Post your feedback in our comment section below, and subscribe to our YouTube channel Project Ventive for more updates.